A steel bar of cross section 500 mm square is acted upon by the forces as in figure. Determine the total elongation of the bar. For steel, consider Young's modulus as 200 gigapascal. So this is the given circular bar which is acted upon by some forces, here 45 kilonewton and here 10 kilonewton, 15 kilonewton and 50 kilonewton. Here are the options: 0.41 mm, 0.61 mm, 0.81 mm and 1.21 mm. So coming to the solution, here we have three sections in the bar. So consider each individual section and consider the forces acting on those sections. So first consider just divide this bar into three sections. Let us say this is 1 and this is 2 and this is 3. Okay, either come from the right side or left side. So come from the right side, that is from the section 3, or come from the left side from the section 1. So we have a leftward force of 50 kilonewton. So the section 1 to be in equilibrium, opposite force also should be in equal to 50 kilonewton, but it is towards the right side. Now consider second section. So here already we have taken 50 kilonewtons towards the right, but here on the section there is a force 15 kilonewton acting towards the right. So just subtract the 15 from 50. So we get here 35 kilonewton towards the left. Now the section 2 to be in equilibrium, another 35 kilonewton must be acting on the other side towards the right side. Now consider 3. Here already 45 kilonewton acting on the section 3 towards right. So now the section 3 to be in equilibrium, another 45 kilonewton should be acted on the opposite side. So now this is the classification of three sections, and we have individual sections as well as individual forces as well as individual dimensions. Here the section first one is 0.6 meters length, and section 2 is 1 meter length, and here section 3 is 1.25 meter length. But the diameter is equal for all the sections, or cross sectional area is equal for all the sections, that is equal to 500 mm square. Now the total deflection of the bar is equal to, so here PL by AE of first section plus PL by AE of second section plus PL by AE of third section. So here area and Young's modulus of the bar are equal. So just take 1 by AE as common, and here we have PL1 plus PL2 plus PL3. So all the values are known values. Here the cross section area is equal to 500 mm square, and Young's modulus of velocity is equal to 200 gigapascal, and here the load acting on the section 1 known value and length of the section 1 known value. So like that remaining two sections also we have the known values. Just substitute all the values so that we get here a value of 1.21 mm. So here the right answer is 1.21, and in the option the correct option is D. D is the right answer. Coil chain of a crane required to carry a maximum load of 50 kilonewton is shown in the figure. Find the diameter of the link stock if the permeable tensile stress in the link material is not to exceed 75 megapascal. So here the given diagram, a coil chain of a crane required to carry a maximum load of 50 kilonewton. You can see here the load applying on the crane, but it is applying on the link stock. So this is the link stock given which is connected to the two cranes, and here the options are 10 mm, 20, 30 and 40 mm. So coming to the solution, here we will have to find out the diameter of the link stock. So here the link stock is subjected to a tensile load of 50 kilonewton. So that means, so this is the given representation of the loaded link stock. Okay, it is carrying a 50 kilonewton load of tensile nature. So here the maximum stress in the link is equal to the ratio of load and cross sectional area of the section. Here A is equal to P by sigma, and sigma is not to exceed 75 megapascal, and P is equal to 50 kilonewton, that is 50 into 10 cube by A is 75 Newton per mm square, and here A can be written as pi by 4 d square, where d is the diameter of the link stalk and is equal to 50,000 by 75. From this relation we can get here the diameter of the link stalk, that is equal to 29.13, so nearly equal to 30 mm. So in the option, the right option is C. C is the right answer. Coupled to a two-stroke engine which produces a torque of 775 plus 225 sin 4 theta Newton meter, where theta is the crank angle. The main engine speed is 365 rpm. The flywheel and the other rotating parts attached to the engine have a mass of 335 kg at a radius of gyration of 150 mm. The power produced by the engine is, here are the options: 1.2 kilowatts, 24 kilowatts, 29.6 and 43.5 kilowatts. So here coming to the solution, we will have to find out the power produced by the engine. Here power produced by the engine is given by 2 by nt mean by 60, where T mean is the mean torque and N is the mean speed of the engine, and here mean engine speed is given by 365 rpm, and we will have to find out the mean torque. Here mean torque is given, actually torque is given by a function of theta, and it is a function of 4 theta, so that here theta is equal 2 pi by 4, that is pi by 2. So generally we represent it as 0 to theta, that is t d theta. So which gives 1 by pi by 2, 0 to pi by 2, and 775 plus 225 sin 4 theta. So on the simplification of this equation, we get T mean is equal 775 Newton meter, and the power produced by the engine is equal 2 pi into 365 into 775 by 60. So which gives a value of 29.6 kilowatts. So in the options, the right option is C. C is the right answer. Crank and slotted lever mechanism used in a shaper has a center distance of 300 mm between the center of oscillation of the stroke, oscillation of the slotted, and center of rotation of the crank. The radius of the crank is 120 mm. Find the ratio of the time of cutting to the time of return stroke. Here the ratio of the time of cutting to time of the return stroke is given by 360 minus alpha by alpha, where alpha is the crank angle. So here let us say this is the distance between the oscillation of the slotted and the center of the rotation of the crank, that is equal to 300 mm. Let us say this is AC, and here the crank radius, let us say this is some CB1 or some B2. So this angle is called this angle is taken as half of the alpha, and this is the angle is 90 degrees, and here it is 90 minus alpha by 2. So here angle we can say that sin CAB1 is equal to opposite side by adjacent side, where opposite side is the 120 mm and adjacent side AC is 300 mm, which gives a value of 0.4, and here angle CAB1 is equal to 23.6 degrees, where angle CAB1 is 90 minus alpha by 2, which is equal to 23.6, and from this equation we get alpha is equal 132.8 degrees. So here from this alpha we can find out the ratio of the time of cutting stroke to time of return stroke, that is equal to 360 minus 132.8 by 132.8, which gives a value of 1.72. So in the option, the right option is D. D is the right option.